I'm going to use base 10 blocks for dividing. I started by modeling 4.4. We're going to be dividing 4.4 by 0.8. And I started by trading the whole flats in for 10 tenths because I can't divide the wholes into groups of less than 1. And I'm going to be making groups of 0.8. So I've traded each of the flats in for 10 tenths. Now that I've got all the tenths, I can start putting them into groups that have 0.8 in each group. So I've made all my groups of 0.8 and I have 4 tenths left over. I can't put them into groups of 0.8, so I have to trade them in for hundredths. And I can line the hundreds up into groups with 8. And I've made a rectangle with a side length of 0.8. So the question is, what's the other side length? In this case, we can count that we have 5 wholes and 5 tenths, meaning we have 5.5. And that dimension of the rectangle is the answer to this division question. Here you can see I've used long division with the traditional algorithm to come up with the same answer, 5.5. So essentially, it's like doing multiplication using 10 blocks in reverse. The area represents the number being divided. One dimension represents the number it's being divided by. And the mystery number, the one you don't know, is the other dimension of the rectangle. So 4.4 divided by 0.8 is equal to 5.5. If we reversed it, 5.5 multiplied by 0.8 is equal to 4.4, which is why we can use the rectangle area model for both dividing and multiplying.